When it's put into a word problem, it says that Bellevue is 30 kilometers north of Air. Churchville is 18 kilometers northwest of Air. Calculate the distance between Bellevue and Churchville. So Air is in the south. I'm going to label that as A. Bellevue is directly north. And Churchville is to the northwest. Bellevue is 30 kilometers away. Churchville is 18 kilometers away. And it wants us to solve side length A. Now, some people approach this problem and say, well, but didn't give us any angles. This is one of the few cases where there is a certain amount of presumed knowledge that you have. One of the pieces of presumed knowledge is knowing that on a compass, north let's use red. North is going straight up. West is going directly to the left. Between north and west is 90 degrees, which means that if I'm going northwest, it's going to be halfway between that 90 degrees and leave you with 45 degrees. The question didn't tell us this expressly, but it's something that just through basic knowledge you should know. So now I know what angle A is, I know what side length B is, I know what side length C is. I'm trying to solve what side length A is. A squared is equal to 18 squared plus 30 squared minus 2 times 18 times 30 times cos of 45. A squared is going to equal approximately 460.32 whatever. And don't forget to square root to get your final answer. A is going to equal 21 kilometers. All right, so that's how we use the cos law in order to solve a side length. In order to solve a angle, we have to rearrange the formula in order to isolate for the angle or cos of the angle, just like what we had to do when we were doing the sine law. Now, you can see that here's the basic form of that rearranged one. B squared plus C squared minus A squared over 2BC. Really, the key in order to doing this properly is if I'm trying to solve angle A, then side length A has to go in the numerator and it's being subtracted from the other two angles. When I moved it over to the right-hand side of the equation, I'm subtracting. If you can remember that, then you're fine. So as soon as I say that I'm trying to find cos of B in the numerator, I got to subtract B squared. And then the other two are A squared and C squared, and it's all being divided by 2 times the other two side lengths of AC. If I'm trying to find cos of C, I know right away I have to subtract C squared. I'm going to take A squared plus B squared, all divided by 2AB. As long as you can remember that you're subtracting the opposite side length squared, you're fine. That's realistically the biggest issue that happens with these. So if it says determine the largest angle in triangle ABC, well, I'm going to just draw a non-right angle triangle. Doesn't have to be perfect. I'm going to label the sides or angles A, B, C, and tells me that side length A is 14.7. Tells me that side length B is 8.9, and tells me that side length C is 12.6. Once again, this assumes that you can use logic. The largest angle in any triangle will always be opposite the largest side length. So if I have three side lengths, largest side length. If I have three side lengths where one is 8.9, one is 12.6, and one is 14.7, I'm solving for the angle that's opposite of 14.7. If it asked me for the smallest one, I'd be solving for B, but in this case, I'm solving for A. So I'm going to say that if I'm taking cos of A, right away, I'm going to remember I'm subtracting 14.7 squared. And then I'm going to put in my other numbers. 8.9 squared plus 12.6 squared all over 2 times 8.9 times 12.6. And then from there, I can simplify this. And get approximately 0.0975. But logically speaking, that's not what my angle is. Remember, anytime that we solve an angle, we're always looking for cos, sine, or tan to the -1 of the ratio. So angle A is equal to cos to the -1 of this. Angle A is going to be 84 degrees. Now, if you have trouble putting this in your calculator, the easiest way to do it is just put the numerator in your calculator, just put the denominator in your calculator, and then rewrite the fraction with whatever the simplified numerator, whatever the simplified denominator is. If you can put it all in your calculator at once, great. If you're not sure if you can, just put in the numerator, state what it is, put in the denominator, state what it is. Same as when we're simplifying the quadratic formula. All right, and for the last example, 2 ships set sail from port P heading in different directions. The first ship sails 7 kilometers to R, and the second sails 8 kilometers to Q. If the distance between Q and R is 13 kilometers, determine the angle between the directions of the 2 ships. Well, they both left from P, so I'm trying to solve based on P. So I'm going to say that cos of P is equal to, right away, I'm going to say minus 13 squared, and this is going to give me 7 squared plus 8 squared, all divided by 2 times 7 times 8. So, cos of P is going to equal negative 0.5 P is going to equal cos to the -1 of negative 0.5, and that's going to give me 120 degrees. Now, anytime that you're using the cosine law, if you get a negative ratio, just remember that that means that it's going to be an obtuse angle. It's going to be between 90 and 180 degrees, just like how we know that anytime in our angles and standard rotation, it's between 90 and 180, it is going to be a negative cos value. All right, go ahead, get some practice.